Hello everyone, today is day 24 of Python Pro from CTC. Today we are going to explore one of the most versatile and powerful data structure in Python, Hashmaps, also known as dictionaries in Python. Hashmaps allow us to efficiently store and retrieve data using key value pairs. If you have ever worked with data that needs quick and direct access, Hashmaps are your go-to tool. So what exactly is a hashmap? A hashmap is a collection of key value pairs where each key is unique. The magic happens behind the scene with each hash function, which converts the key into an index in an underlying array, allowing for rapid access to the associated value. This means that hashmap operations such as insertion, deletion, and retrieval can be done in near constant time. Let's dive into the basics. We will be creating dictionaries that are hash maps in Python using curly braces. Within the curly braces, we will be using keys and then their values. So to find the length of the dictionary, we will just use len of the variable name, then dictionary.key of just retrieve the keys of the hash map, then dictionary.values to retrieve just the values, then dictionary.items to retrieve everything. For example, let's run this function now. Let's define a hash map here. So for key and items in d.items, d.items will have everything. We can just print this using an f string. Key as key, then value as values. So we got everything we need in here. Let's learn a built-in function in Python called enumerate. To use enumerate, create a list here. So we will create a variable where we will use the enumerate function. Enumerate of the above list. What we are going to get as d, an enumerated object at this memory location here. So what we can do to convert this enumerated object into a hash map, we can just use another built-in function called dict_of. Let's use that. Hash equal to dict_of d. See, we have got hash as 0 index, then the 1 as value, 1 and 2, 3, 4, so on and so on. So you understand the concept, right? So here we are going to use the same concept for the previously learned sum, two sum. So here is the two sum approach I have all studied. So this is a rookie approach. Here what we are going to do is we will just code two loops to iterate and add every two elements and check if it is giving us the target value, that is 9 here. So we should get the output as 0 and 3. So we can code that easily as in two for loops. For I in range of len of nums to go through till the end of the list. Then another pointer j in range of I plus 1. So we don't have to, cause here there is a condition called you may not use the same element twice. So I plus 1, so we won't be iterating the same element twice till the end of the array. Here we will just add nums of I with the next pointer nums of j and check if it is equal to target. Then if we got that answer, we will return I and j. Let's see what happens here. We got every case accepted. So but there is a different way of doing this. Let's see what is that. What we can do now is, as you know, lookup in dictionaries are O of n time complexity when compared to O of n in list. So we can just we have the list here 2, 11, 15 and 7. We know the target is 9, so we should get the answer as 0 and 3 here. What we can do now is, we can just iterate through the list with the enumerate function. So we will be storing every index as well as the value. So we will have 2. What we are going to do is, we will take the complement of the target and the value I have got in the array. So 9 minus 2 is 7. We have got 7 for the first iteration. What we have to do now is, we just have to check if 7 is in the dictionary or not. We can do this by storing all the elements in a hash map at the beginning of the list, but there is a different approach where we can do this. Let's say, what if the target is 4? We are going to iterate through the element. If we are going to store all the elements in the beginning of the program, we will have 2, then we will be iterating through everything, right? So we will have 2 plus 2 as 4, but that is not the case here, because we can't use the same element twice. So what we can do here, we can just go through every element, then after going through the element, we can add it to the hash map as values mapping to the indexes. So we can just look up with the values themselves. So what we are going to do, we will compare 9 and 2. 9 minus 2 is 7. So we will check, initially the dictionary is empty, right? So we will check if 7 is there in the dictionary. The dictionary will be empty, so there will be nothing. This table will not be there by that time. So what we will be doing, we will go through the next iteration, but we will store 2 and 0 in the hash map. In the next iteration 11, we will compare 9 and 11. So we will get minus 2. We will check if there is a minus 2. No, there is only 2 and 0 here. So we will add 11 and 1 to the dictionary. Then we will go to 15. 15 and 9, we got minus 6. We will check if there is a minus 6. We got 2 and 11, no minus 6. So we will go through the next iteration, adding 15 and 2 to the array. Then we will go to 7. 9 minus 7 gives 2. We will check if there is a 2 in the dictionary. Oh, here we have got a 2. So we will, what we are going to do, so we will just return the 7's index, that is 3, and 2's index here we have stored already, 0. As we are just using only one for loop to iterate through the list here, and the lookup for dictionary is O of n, this is the optimal solution for the two-sum problem. That is providing the solution with O of n time complexity. Let's do this the optimal way. Here we will just initialize an empty dictionary. I will go through the elements in the list using the enumerate as we have saw before. Enumerate of nums. We will use a different variable complement to take the difference between the target and the num, that is the value we have taken from the list. So we will check if the complement is in the hash map as I have said before. If complement in hash, return hash of complement and I. But for every iteration, what we will do, we will assign hash of num is I, that is mapping the value to the index, not the index to the value, but value to the index. So if nothing is found, we will just return an empty array. So let's see if this runs. Yeah, this is running perfectly. We have got every case corrected. Let's submit and see what happens. Yeah, here we go. We have got every test cases passed. Let's see another problem here. Roman to integer, where you have to convert Roman numerals into actual integers. The problem statement might seem quite bigger, but it's an easy one. Let me summarize it into quite a few sentences. So as you can see, Roman numerals are only represented by 7 symbols. As you can see here, I, V, X, L, C, D, M, which has its corresponding values. So the Roman numerals usually go in a decreasing order. That is, it will start from the highest value and go to the least value. But there are some cases which they might be differing. For example, 2 is represented with 2 i's, which is the least value, that is 1. Then 3 we will do the same thing. But for 4, what we are going to do, we will take the symbol for 5 and write it after the symbol for 1. That is, we are literally subtracting the value, the lesser value from the bigger value. That is, if it is going in the usual form, that is a decreasing order, from m to I, we are going to just add them up. But if it is not following the regular rule, that is going from smaller to bigger, we will just subtract it from the result. Let's have a good explanation here. So here we have got 995. So let's take C. C is 100. We got 100 in the counter now. But after that we got M. M is higher value. So what we are going to do? Subtract 1000 and 100. So we have got 900 here. After we have got 900, we have got X. What is X? X is 10. We have got 910 now. But what we have got now? C. Again a bigger value than X. So what we can do now is subtract 10 from 100. So we have got 990. We have got 900 by subtracting 100 from 1000. Now we have got 90 by subtracting 10 from 100. So adding them up, we have got 990. Then we have got V. Straightforward, we got 5. So it's 995. You see how this works, right? If it is going in a decreasing order, we will just add them up. If it is increasing, we will just subtract them. So let's see the solution here. So I have typed out the values in a hash map. This is the best way to do it, because the lookup in a hash map is O of n. What we can do now here is we can initialize another variable to store the result, and we will create a for loop. Len of s. S is the string we have got here, that is the Roman numeral which we will be converting. Len of s. So what we can do now is we will create an if condition. If I plus 1 is lesser than len of s, to have the iteration in bounds and not go out of bounds. Because if we are going to check for every element, if the next element is bigger than or smaller than the previous element, we might end up in out of bound exception. To prevent that, if this is true and the hash of s of I lesser than hash of s of I plus 1. That is, we are checking if the next element is a greater element. That is, if we have got m here, we are going to check, let's see, we have got v here, I here, let's see, we have got I here. We are going to check if the next element is greater or smaller than this. Here we have got I, then we will be checking the next iteration if it is there or not. So it is there, so this condition becomes true, so there is no out of bounds. Then we will go to this condition, checking if hash of I, what you have got here, 1 is lesser than 5. Yeah, it is true. So what we can do is, we can just subtract it from this, the same value, hash of s of I. If not, we will just go to the basic condition, we will just add them up. At last, we will just return the result. Go through the program again, we will use this example. So we have got m for the first iteration, m's value is 1000. We will check for out of bounds, it is not out of bounds. So we will go through this condition, if the next element is greater than 1000 or not. So it is not greater than m, it is 100. So we will just add it, we will use this, we won't be using this if condition and we will be skipping this. We will use this else condition, so the result will become 1000 now. We have got 1000 as result. So the next iteration, C. Now for C, we will go through the same loop, no out of bounds error. So we will compare C with the next element. The next element is m. C with m, we have got this condition as true. So what we will be doing, we will be using this condition. So we will be deducting C from the result. What is the value of C? 1000. What is the value of C? It is 100. So we will be deducting 100 from the value 1000. We have got 900 here. Again, we will go through m. This condition is true again. Then we will go through this condition. It is false because x is lesser than m, it is going in the normal flow. So we will just add it. We have got 1900. As we are using the else condition, we will just add it, 1900. Again we have got x value is 10. We will just use this if condition, cause no out of bounds error, and the next element C, which is 100, is greater than 10. So we will just deduct 10 from the result. So what we have got here, 890, 890. Then we will go to the next element, which is C. Of course this condition is true. Then what for this condition? This condition becomes false because C is, that is 100, is greater than 1. So we will just add it. Now we have got 1990. So we are coming to the next element, that is I. No out of bounds error here. What we will do again, as we are using AND operator here, we are going to check both condition, and only if they are both true, we will be proceeding to this if condition. If at least any one of them is false, we will just go through the next condition. So we will be checking for out of bounds for I, no out of bounds. So we will be comparing I and V. Of course 5 is greater than 1. So we will be using this condition. We will be deducting 1 from here. So it will be as 1989. So at last we are here with the last part of this string. We have got V. It will be checking for out of bounds. Yeah, it is, this condition is false as we have reached at the end of the array. we can't go any further, so it will throw an out of bound error if we are going to use this condition. So we will use the else condition as this is false. So we will just add 5. If we add 5 to 1989, we got 1994. We got the exact output. So let's try to run this. We got every case accepted. Let's try and submit. Yeah, we have got everything accepted.